Hi, welcome back to Outsmartable Educational Videos. Hope everything's going well for you. Today we're talking about graphing trigonometric functions. Last time we looked at right triangles and in particular the unit circle, you may recall. And I've added the radian measure to each of these commonly used angles. You need to become familiar with the radian measure as well as the degree designation for these commonly used angles, 30, 45, 60, 90, and all angles for which those are reference angles. Here's the conversion from radian to degree and vice versa. These cosine and sine functions are actually continuous functions with an infinite domain ranging from negative infinity to positive infinity inclusive. Tangent is not continuous. Remember that the tangent is equal to the sine divided by the cosine. So everywhere the cosine has a value of 0, the tangent has an asymptote. And it has a period of 180 degrees as opposed to 360 for the sine and the cosine. But let's talk about how to graph modified functions of these trig functions. Remember the rigid and non-rigid transformation discussion in intermediate algebra? Well, that's what you use when modifying these trig functions. Here's a modified trig function where A serves to identify the amplitude. The period is equal to the normal period divided by the absolute value of B. Shift vertical up or down is identified by the value of D. And shifting to the left or the right is equal to C divided by B. Let's try one of these problems to see how this works. I always like to start with the shift up or down. In this case, 2. The amplitude A is 3. The period is going to be, it's not altered. There's the coefficient B is equal to 1, so that's 360 degrees. And the shift to the left or the right, we have an x minus pi, x minus 180 degrees. So it's going to shift this thing. Recall from your intermediate algebra discussion, it's going to go to the right 180 degrees. Or to the right pi radians, whichever you prefer there. Okay, well, the sine function normally has a midpoint at 0. Midpoint is typically at 0. The shift up or down, take that midpoint and shift it up or down, and the new midpoint becomes 2. The amplitude, that's a value that's equal to the distance from the midpoint to the maximum value. It's also equal to the midpoint distance to the minimum value. So if we go 3 up from 2, we get 5. We go 3 down from 2, we get minus 1. So that's the new range, if you will, for this modified sine function. And the period is still 360 degrees. So let's see, we have 360 degrees here. Here's 0 degrees. Here's 360. And at 0 degrees, the sine is going up. There you have it. But now we're shifting to the right 180 degrees. That means we're picking this graph up and we're moving it 180 degrees to the right. Well, what I like to do rather than picking up the graph and moving it 180 degrees to the right is I like to just take the designation of the 0 degrees and the 360 degrees and move those 180 degrees to the left. And that gives you your modified graph. It starts instead of going up at 0 degrees, it's going down at 0 degrees. So here's your modified graph right here. Okay, how about this next one? There is something in this one that we haven't talked about yet, and that's a reflection. Remember, if you modify the entire value of the function by multiplying it by -1, that it reflects the graph over the x-axis, and if you just multiply the value of x by -1, it reflects that curve over the y-axis. So here, let's take this piece by piece. What's the shift up or down? We're not shifting up or down, so it stays the same. How about the amplitude? The amplitude is 1. We're not really increasing or decreasing the amplitude. Let's see, how about the period? The period is equal to 360 divided by absolute value of 2, or 180 degrees. Or if you prefer, pi radians. How about shifting to the left or to the right? There's no shift to the left or to the right, is there? Okay, so we've got everything we need here. The cosine has a midpoint at 0. The amplitude is 1. There's our amplitude. The period is 180 degrees, so we've modified the period. At 0, the cosine has a value of 1. So here we go. Here's our, that's equal to the cosine of 2x. Let's see, the period again is 0 to 360 degrees. But oh, look at this, we multiplied the whole shooting match times -1. So we have to reflect this thing over the x-axis, don't we? So instead of 1 here, we're starting at -1. So in black, we have y is equal to negative the cosine of 2x. We've reflected this over the x-axis, so now it starts at -1 and goes up, and here's a period of, let's see, got a period of 180 degrees. Sorry, period is 180, so there's 180 degrees. Period is 360 divided by 2. Okay, very good. How about the third one? Let's see what this one, can you tell what the amplitude and the shift is equal to for the third one? Looks like we're shifting up 4 units. The amplitude is 2. The period is 360 divided by 3. And the shift left to right is C over B. Negative 120 divided by 3 is negative 40. So it goes to the right 40 degrees. The graph shifts to the right 40 degrees. Okay, so this is a cosine function. Typically it has a midpoint of 0. The new midpoint is 4, isn't it? New midpoint is 4. We're shifting up 4 units. The amplitude is 2, so we go up 2, we go down 2. Maximum, minimum. The period is 120 degrees. 0 to 120 degrees. Cosine at 0 degrees is at the max value. And we're shifting this thing to the right 40 degrees. So instead of shifting the graph, picking it up and moving it 40 degrees to the right, let's take the vertical axes and move them 40 degrees to the left. Let's cheat here. So this becomes our new 0 degrees. It's our new 120 degrees. And there you have it. There's the graph of this third modified cosine function. How about the next one? Next one is a tangent function. Now your tangent function, remember, has typically a period of 180 degrees. That's the number of degrees that it takes to complete one cycle. And then it repeats another cycle every 180 degrees. Okay, so look, for your tangent function, it's just a little bit different here. We're still dealing with rigid and non-rigid transformations, but instead of a period of 360, it has a period of 180. And the amplitude, we really don't need to talk about an amplitude on the tan, because it always goes from negative infinity to positive infinity, whether you increase, stretch it or shrink it, it's still going to go from negative infinity to positive infinity. So the amplitude is a non-issue for the tan function. The amplitude. Are we shifting up or down? No. What is the period? Well, the period is 180 degrees divided by b. In this case, b is equal to 1/2. 180 degrees divided by 1/2 becomes 360 degrees. Are we shifting to the left or to the right? No, we're not. So this again is 0 degrees shift. But the main thing that modified here is the period. So we, at 0 degrees, we still have a value of 0 for the tangent. But now the period is equal to 360. Instead of equal to pi, it's equal to 2 pi. So now we go from minus pi to positive pi. And then it repeats again every 360 degrees, or every 2 pi radians. Okay, how about this last one? No.
Go.
Let's see, we have an amplitude of 2. Let's see, to determine the period, we have to divide 360 by the absolute value of 3, which gives us a period of 120 degrees. Shift left to right is equal to 45 degrees divided by 3. That's 15 degrees, positive 15. So we're going to the left 15 degrees. We're moving the graph 15 degrees to the left. Okay, so we're dealing with the sine here. Typically it has a midpoint of 0. New midpoint becomes 2. Typically it has an amplitude of 1. Distance from midpoint to max, or from midpoint to min. New amplitude is 2. So we're going up 2, and we're coming down 2 to go to the max and to the min. The period is 120 degrees. Instead of 360 degrees, it's 120 degrees. At 0 degrees, the sine is going up. So there you have a complete cycle from 0 to 120 degrees. But now we have to shift this graph 15 degrees to the left. What's the easier thing to do? Rather than picking the graph up and moving it 15 degrees to the left, let's move the y-axis 15 degrees to the right. And there you have the graph of number 5. Okay, that's all I've got for you today. Thanks for stopping by. Hope you have a great day.